Can you give me a thumbs up if you got the record message, just so we can make sure, yay, that it's doing it correctly? Fabulous. So thank you to those who are joining us asynchronously. You will carry out this exploration with your teams and then complete the quiz at the end to earn your credit. So, like I mentioned, we are in TEAC 59A, Earth's rotation. This TEAC has two components to it, so it's going to be kind of fast and furious today to get all of the information to you guys. So, thank you for joining us along this ride. Ask us any questions that you may have, and know that the information we cover at the end is all, well, even with Amy's Model Teach, it's all found in your curriculum document. So if any point you have questions, go there, reach out to us, because it's going to be a jam-packed session today. So please make sure you have these items available for you. If you're watching this asynchronously, now's the time to go ahead and pause and gather these materials. You will need these to carry out the exploration. So this is your lovely science team. I am Jenna Hudan. You see Amy Snyder there, and then our wonderful Science Social Studies Academic Tech IST. I think I got all that correct. Cassandra Hartman, and we will be supporting you all today during this exploration of TEAC 598. So just some quick norms. If you can please keep your camera on and use the chat, AKA our bit.ly Google form that we're working on at the moment, to be able to communicate with us. We would greatly appreciate it. And please honor our time here by staying till the end and filling out the feedback form. We really go through that feedback form and take your feedback to heart and make changes to our virtual PDs. And so know that as we've gotten feedback along the way, our virtual PDs have just gotten better and better. So we greatly value your feedback. So please give us some quality feedback. If you have any questions as we are going through this, you may drop it in our Google document that we are working on. And we will be sure to address those. If by some chance we cannot get this document going, you're more than welcome to unmute yourself too. But I think we might be reaching our document endpoint. Cassandra says we're good to go. Cassandra, do you want me to stop sharing so you can share the bit.ly? Yes, okay, I'm gonna stop sharing, everybody.
Hi guys. Okay, so since it's not working, I'm going to show you the screen. You'll see at the top there is the bit.ly, so it's super simple. Day with a capital D, night with a capital N, chat with a capital C. You'll see that it's just really easily set up. Create it like a normal chat. On the left side is where you guys can operate questions, thoughts, answers, whatever. If anything that you put in there requires a response from us, or it's a question and you need it answered, we'll put our response to what you said on the right side. Otherwise, just work your way down the left side for anything that you need to put into the chat. Does that sound fair to everybody? If not, let us know. Okay, so there it is again, one more time, the bit.ly. And then Jenna, whenever you are ready, you can stop my share and take over and do the things.
Okay. So just real quick, it's bit.ly/day-night chat, and the first letter of each word is capitalized. So I am going to now share my second screen. Here we go. All right. Everyone see my screen? Yes, beautiful. So hopping into our historical data review, here you can see our STAR standard analysis for this TEAC 59A. In the STAR for the school year 2024, our district scored a 46%. And then for 2025, the STAR test that just occurred, we see a drop to 38%. So this is our evidence as to why this is a hotspot TEAC for us, right? Interestingly, you see that our unit assessment standard analysis for this TEAC is at an 81%. And so in a moment, when we look at the STAR question and in the unit assessment question, we're going to kind of brainstorm why we might be seeing this discrepancy in the data here. So we're going to go ahead and unpack this standard. You see our TEAC here. I want you to take a moment to read that TEAC and focus on the verbs that jump out at you for this TEAC. I'm going to pull up that chat. If you can type in the chat, aka Google Doc, the verbs that you're noticing and seeing.
If you're not able to type, refresh the document and you should be able to go.
There we go. I see some cursors in there now. So I see demonstrate. Yes, demonstrate and explain. So that's what, remember, these TEACs are what the students are doing, right? So we need our students to demonstrate and explain here. And so when we look at our learning targets, we see that the students will observe and create models to explore and explain the day-night pattern caused by Earth's rotating on its axis. And then they will also observe the location of the sun in the sky and shadows at various points of the day to identify patterns that occur. And so when we look at that information that we just mentioned, our main verbs are demonstrate and explain. And then how are we going to be learning the rest of this TEAC? We will carry out our learning targets that we have generated for you guys. So next, when we focus on our standards here, we see our SEEPs, or Science and Engineering Practice, and our RTC. And so looking at our Science and Engineering Practice and our RTC, you can see that those two make up that TEAC, right? Last year we had some PDs around SEEPs and RTCs, and I know it's still kind of a work in progress to understand this idea of the SEEPs and the RTCs, but I really want you to see that the SEEP and the RTC make up that TEAC. And so when we are carrying out this TEAC in fidelity with the content and the curriculum, you are also carrying out the learning of the SEEP and the RTC that corresponds with that TEAC. So looking at the unit assessment data, this is our unit assessment question in the curriculum. And I want you to just glance at this really quick, take a moment to kind of take it in, because remember I asked you, we were going to try to figure out why we might have that score discrepancy. And so now I want you to take a look at the star question here. In the chat, can somebody, anybody, if you feel comfortable enough, give me your inference? Why do you think when looking at our assessment question here and our star question here, there may be that score discrepancy? I'm also going to show you two other star questions. There's not a model in the district test question. Okay, yeah, the star question is more wordy. The star question is more wordy. There's a model. There's different ways of kind of understanding this content, right? And when you take a look at the question we have here, that's a pretty straightforward question, isn't it? It's relatively easy to answer, and it's focused on, why day and night occurs. And it's missing shadows even, right? And so that tells us to make changes. And so we have been making changes to your fifth grade assessments as we are looking at our hotspot TEACs and the correlation with these kind of hot spots along the grade levels as well. So that lets us know, okay, we need to put more rigor into this question because this is how it's being asked on STAR, and this is how it's being asked of you in the classroom. And so we need to make those more closely aligned. Does that make sense? I see three-part questions related to one image. Very, very good. Okay, guys, so the lovely Amy is going to hop into the model lesson with you. Amy, I need to stop sharing, right? So you can share?
If you can leave it there for just a moment, and then I'll let you know when to stop, and then I'll take over the sharing.
Yes,
Hi,
ma'am.
everyone, fifth grade teachers. It's great to see you. So we're going to get started with the model lesson. So just so you know, for background, there are 2 learning targets that we use to cover this TEK. So there's 2 parts of it, the day and night cycle, and also the changes in the appearance of sun and shadows. So for the model teach, I'm not going to go through the entire 5E for both of the learning targets just because of time constraints, but I'm really going to focus on the explore and explain parts of the hands-on labs that go with these learning targets. So just so you know, it's not a full 5E, but we're really going to focus on giving you the opportunity to test these hands-on experiences for your students, record data, so you can start to brainstorm how you're going to facilitate this in your classrooms, if that makes sense. Okay, so our guiding questions, we have 2. So the first one is, how can we model day and night on Earth? And then our second one is, how does the appearance of the sun and shadows change throughout the day? And so today we are going to be working with models. So we're going to create a model to show how we can demonstrate the day and night cycle. And we're also going to create a model to show how the appearance of the sun and the shape and size of shadows change throughout the day. And so as we're creating our models, we're going to brainstorm some of the advantages and limitations and how close the models are to the real life phenomena, and then compare so we can really understand those processes that cause the phenomena. So we're going to explain the day and night cycle using our models and then further develop our understanding. And so as we're creating our models and really studying these patterns, I want you to think about how the patterns are represented in our model. So thinking about your RTCs as you're making the models and recording your data, think about how does this demonstrate a pattern, and how does this show a cause and effect relationship, and how is this a system? So there's multiple RTCs that you can connect to both of these hands-on investigations. So you really want to present them as options and see if the students can make the connections as you are making the models and then recording the data. Okay, Jenny, you can stop sharing and then I'll start to share. Okay, very good. Okay, can you all see my screen, my notebook?
Yes, ma'am.
Very good. Okay, so we're going to start off with the hands-on investigation for the day and night cycle. So if you have your Savas consumable, this is adapted from the Savas hands-on station. So in your volume 2 of the Savas consumable workbook, I am on page 17. And so I am using that hands-on station and activity as I'm going through this, but I'm going to be recording data in my notebook just so there's more space for me to draw the model. So we recommend that you do that as well with your students, because the hands-on activity page, it doesn't give them a lot of space to record their drawing. So we really want to make sure they have their high quality science drawings with the pictures and the labels. And so we recommend doing this directly in the science notebook like we see here. So I went ahead and cut out the model and then evaluate, so parts 1 and 2. And the materials that you will need is your wooden dowel and your styrofoam ball, and you'll also need a flashlight. So we are going to be modeling what causes the day and night cycle. So we're going to be creating a model. So what you're going to do, if you have them with you, teachers, if you can go ahead and get your wooden dowel and your styrofoam ball. And today we are going to use this model to investigate what causes day and night. So to model Earth, we are going to push the wooden dowel through the foam ball. So here, the ball represents Earth, and the dowel represents Earth's axis. And then our flashlight is going to be representing the sun. And so what I'd like for you to do first is you have this space in your notebook here. I'd like for you to take some time to draw the model that you created. So you're going to draw the materials of your model. So the styrofoam ball, the wooden dowel, and your flashlight. We're going to draw that in our notebook. And we're also going to label them with what that represents. So teachers, if you can go ahead and take a moment to do that, so you can do that in just a notebook if you have it, or an extra sheet of paper, just so you can practice what the students are going to be doing. So I'll give you a couple minutes to go ahead and draw and label your model. Okay, so hopefully you've had a couple of minutes to draw your model in your notebook, and we've clearly identified with labels. So we put what the materials are and what they each represent. So this would be an opportunity to show your students that the Earth is at a tilt on the axis, and that when it moves counterclockwise. And within our curriculum resources, there's an image that you can use as a visual for counterclockwise and get them to practice what it means to move counterclockwise and what direction that would be. And so you can go over that and how to use the model in this step after they record their drawing. So once they record their drawing, then that's a really great opportunity for you to go in and think about the advantages and limitations of the model. So asking them questions like, how is this similar, or how is it different from the real life phenomena? So students may say things like, well, this obviously isn't as large. It's going to move at whatever speed that I choose to move it, and it's more convenient for me to study versus waiting a whole day. So all of those things they can point out as advantages or limitations of the model. And those are conversations that you can have prior, just by observing the model, and then after the investigation as well. So you'll start now in the notebook. So if you look at the Savage hands-on station card, like we mentioned earlier, there's not a whole lot of space for them to record their data in the drawings. And so it's a lot more efficient for the students that they have more space to record their drawings in their notebook, just so they can clearly include their labels and really see that pattern. Excuse me. So if you can take a moment to go ahead and set up in your notebook, students, the times that we're going to record our data. And then in this space, this is where we're going to show our drawing of our model. And again, the model includes all of these components. The sun is our flashlight, and then the Earth, and on Earth's axis, which is our styrofoam ball and the dowel. So now what you're going to do is we are going to mark a point using a marker, or you could also use a thumbtack as well if you have it. So you're going to mark a point on the Earth, and that's going to represent a person at some position in the earth. So about in the middle here, you're going to mark a point on your styrofoam ball. So that's going to represent a person that is on earth. Okay. And at that point, then we're going to get our flashlight and we are going to show the students and model what that would look like. So, and I'm also going to turn down the light so you can see and give you some tips on how to record data and how to show the students how to draw this in their notebooks. Okay. So here is my person, and then I have my flashlight here. So I'm going to put the flashlight, and the person is going to be directly facing where the flashlight, where the sun is. Okay, so when they're recording their data in their notebook, sometimes it can be tricky because you're trying to record a 2D representation of a 3D model. So a trick that you can do is have the students record their drawing from an overhead view. And so what that would look like for this image, so the person is directly facing the sun. So when I draw it, if I look at it from directly overhead, it would look like this. So my person is here. And then the sun is coming, the flashlight light is coming from over here. So there's my light. And then the person is here. And it always is helpful just for visual support for the students is I would always highlight or color that half yellow to show that that was the side that was lit up. And so again, if you use a thumbtack or a push pin, you can see it more clearly, but have the students record their data from an overhead view, because then they can see how the position of the person is changing. Okay, so again, we're going to remind you that the Earth is going to spin counterclockwise. So I'm going to give you some time to record your data. And so you're going to explore how is the change in what part of the Earth is lit up as it spins counterclockwise. And we're going to record the position of the person as well. So go ahead and take a moment, teachers, and record that data in your notebooks. Okay, so I'll give you some time, and we love to highlight some people. So I'm going to stop sharing and then give you some time to work on recording that data, and we can highlight Okay, about 1 more minute, and then we'll go ahead and move on and look over our data together.
Don't worry, Edna, we're just spotlighting you because y'all are doing good stuff. Don't be sorry, you're good. You didn't mess anything up.
Amy, can you show them the labels that you had again? Some of them want to be able to see all 4 of them.
Yes, I was just getting something going with a sample of it. So give me just a second, I'll put them right back up. Okay, here we go. There we go. Okay, can you see it? Okay, so here's the labels that we put. And so I wanted to also show you within your curriculum where we have this lesson in a scripted format for you. We also linked the sample anchor chart as well. Can y'all see that on your end, what I'm sharing? Okay, so this also has the same times and also what students would see from the overhead view. So you can see that as the Earth is rotating or spinning counterclockwise, so here the person is directly facing the sun. So that would be middle of day. And then as the Earth spins, rotates counterclockwise, so we can see that the person is now spinning away from the sunlight. So that would be at sunset. So they would be entering nighttime. And then as the Earth spins counterclockwise further, so the middle of the night, the person would be on the other side of the Earth that is not experiencing sunlight. Then it continues to spin. So then the person is now about to spin or rotate into sunlight again, which would be the sun rising. So again, it's much easier to see that trend and what we want them to see with the day and night cycle if they're recording from an overhead view. Just what their drawings and their data will make more sense that way. And I think the yellow or highlighting really helps as well because they can clearly see that the side that is not colored yellow, that would be nighttime. Very good. Okay, so now let's look back at our data. So I'm going to go back to my notebook here. Okay, so at this point, you would have the students look at their own drawings and you can create a class anchor chart like the one that I showed you and start to generate their own explanations. And so you can use your observations and ask them, what do you think causes day and night on Earth? So why is it sunlight sometimes or nighttime the other times? And they can use their model and their data to answer that question. Okay, and then once that is complete, you could also have them add in their notebooks. We want to make sure that they know that one complete cycle is 24 hours. So you can add that directly to their data and tie it to their experience. So they know that from this position and then to rotate again is a 24-hour process. So as they have that experience, they're tying in the vocabulary and then they're tying in the definitions as well with what they experienced in their Explore. Okay, so that is the first part. So that is Earth's rotation and the day and night cycle, the hands-on part. So now we're going to go into the appearance of the sun and shadows. So what causes the appearance of the sun and shadows to change throughout the day? So we are also going to be using a model for this as well. And so I'm going to show you, let me stop sharing here. If you can give me a moment. Let's stop share here because I'm going to show you what you need to do this. So we asked if you can bring either chart paper or butcher paper. If you don't have that, you can even line up on a desk like a couple of pieces of copy paper or even notebook paper, and that'll work fine. So I'm going to show you, if you just give me a moment, I'm going to show you the chart that I created, and then you can mimic that in your classroom and with your teams so that we can go through this together. Okay, so this way. I'm just adjusting here. Okay, so let me share my screen. Okay, can you all see screen 2 with the desk? Very good. Okay, so I'm gonna go over here. So I have a piece of chart paper here, and then I put the directions. So I put east, but I just did it this way because of the orientation of where I am positioned. Now, usually, but I wanted y'all to see it easier. So I know it's the directions are flipped because I'm showing it from this perspective, but we just want to make sure that they have labeled the east and the west. So it doesn't matter which side as long as they have it labeled. So on your butcher paper or the chart paper, you're going to put east and west. And it doesn't matter what side. No, usually we see it on paper, like in textbooks and things on the pictures on STAR. Usually we'll see the east on the right side, but that's not always the case. It could be switched as well. So we want to practice with both, but as long as they have east and west labeled. And so what you're going to do next is you're going to show them that that represents the flat land, right? And we're going to also use our flashlight to represent the sun as well. So we're really focused on shadows and how the appearance of shadows in the sun change throughout the course of the day. So next, what you'll do is take a marker and you're going to put that in the center. Okay, so you're going to put your marker in the center, and this is going to represent a person or a tree, a telephone pole. And what you're going to do is your flashlight is going to represent the sun. And so we're going to let the students know the sun is going to rise in the east and sets in the west. And so when I model the sun, I'm going to move I'm using my phone as my flashlight, but I'm moving it like this. And I'm paying attention to the shadows. So first, I'm going to just give you time to just explore that. And you can also trace the shadow changes that you see directly on the chart paper or whatever paper you have available. You can color code them. You can put time estimations of the time of day as well. And you just want to just collect your data first. So you're going to observe how the shadow of the marker changes and then record that directly on your chart paper. Okay, so we'll give you a couple of minutes to do that.
I know it's kind of hard to see on Amy's page because of the way the lighting is in her room. You can already see a shadow, but when you do it yourself, you'll really see that shadow start to move.
I know, and I see that I'm gonna take off the north and south because that's confusing the way that I'm just gonna leave east and west. I just didn't want to confuse y'all because the way from my perspective versus y'all's perspective. So I'm gonna X that out, but as long as they label the east and west and they know that the sun rises in the east, sets in the west, and you're just paying attention to the shadow changes of the marker. Okay, so we'll give you some time to do that, then we can highlight some teams as well. Okay, cool. So as the students are, and you are now exploring and collecting your data by just noticing the patterns, right? So this connects back to the RTC of what patterns do we notice in the changes of the size of the shadow and the shape and the position of the shadows throughout the day. And so at first, they're just collecting those observations in the data. It could even be directly on the chart paper. But ultimately, we want them to add those to their notebook, right? Because we want to connect the academic vocabulary in the big picture that we want them to see. So I'm going to show you that part now. So maybe they at first created their data or traced the shadows directly on the paper. So now we're going to go into our notebook so we can really address the academic vocabulary and really make sure that they understand the pattern and that cycle. So I'm going to share my screen again. Okay, can you see my screen? Notebook? Very good. Okay, so in the notebook here, the way, and these are also linked in the script that we have for this lesson. So we set up how to set up the notebook so you can see the trend in the shadows. And so we want them to realize that as the day, throughout the day, the shadows change, right? And so what they can do is draw their model. So this, sorry. This would represent my marker. And I try to keep it in the same position for all of the drawings. And so I can even show directly on here. So here's the marker. And then here is my sunlight. So when the sun is low, right? So when the sun is low, when sun is rising in the east, what do you notice about the shadows? Okay, I see Amanda. Yes, the shadows are long, right? So when the sun is low, L, the shadows are long. So when I'm recording data for this, I can draw, okay, in the early morning, I know that the sun rises in the east. So the sun is low and the shadows are long, right? And I know that if the sun is in the east, then what direction is my shadow? What's the position of my shadow would be the west on the other side. Very good. And so you can model that for them and show even in your notebook like I'm doing now. So what do we notice? Okay, in mid-morning, so the sun is not quite directly overhead, but it's headed that way, or it appears to be moving that way, right? So around late morning, like 10 a.m., what do you notice about the length of your shadow? How is it changing? It's getting shorter, right? And so we could record that as well. Okay, my sun is appearing to rise or get higher, and my shadow is getting shorter. Okay, so I'm going to keep moving the sun. So sun appears to move, so it's directly overhead or at its highest position at around noon or midday. So what do you notice about, there we go, about the shadow, the length of the shadow? When the sun is directly overhead, it would be the shortest, right? And then you can see that as we move the sun again, it's getting longer and longer and longer and longer. So again, when the sun is low and the sun is setting, the shadows are long again, but on the other side. And so what this could look like as they're recording this in their notebooks, they're connecting it to that experience that they had with the marker. And then I'll also show you a completed version of this as well, which we have linked. Sorry, my document camera is giving me a little bit of a hard time. Here we go.
Amy, when you have a chance, it's been asked if you could explain the sun anchor chart one more time. So when you're done.
Yeah. Okay, so this would be the shadows one. Can y'all see this filled in? So we link those in the script as well for shadows. So when the sun is low, shadows are long. In whatever direction the sun appears to be, the shadow position is the opposite. And then we can see that as the sun continues to go up, so late morning, 10 a.m., it's getting shorter. Around noon, directly overhead, the shadow is the shortest. And then it starts to set, right? So it starts to set in the west, and so it's getting longer. And then when the sun is low again, shadows are long. Okay, and we also included options in the curriculum as well for you to take your students outside, which would be ideal to go and trace shadows. So this would be best somewhere where it's not going to get blocked throughout the day. So a good place could be like the basketball courts on the blacktop, or even trace each other's shadows. They can go and stand in a certain position and record the direction that they're facing. And then trace shadows throughout the day and then put timestamps. So that's an option as well and would be wonderful. We have resources for that in the curriculum as well. So lastly, so you said somebody had asked about the anchor chart for the Earth's rotation, right? So this, again, we talked earlier about how for the model teach, this model teach was covering 2 learning targets. So the first learning target that's covered is Earth's rotation and how that causes the day and night cycle. So this anchor chart that I'm showing now goes with Earth's rotation. So the model would be using your styrofoam ball and the dowel and the flashlight. That would be the spin. So it spins counterclockwise, and at any given point, only half of the Earth is lit by the sun. So that would be experiencing day, and the half that is spun away from the sunlight would be experiencing night. And so this anchor chart is like the class set of data or the big takeaways that we want students to understand of how Earth's rotation causes day and night. And so the reason why I put the overhead view is because it's much easier for students to see the pattern when they look at it from the top, because when they're recording, they're trying to record a 3D model on a 2D paper. And so if you put, especially if you put a push pin, it's easier for them to see that wherever that person is, if it's where the sun is lit, it's daytime. And as Earth rotates, they're going to rotate out of the sunlight. And so that's what I tried to show in that anchor chart. Was that helpful? Hopefully that clarified. Okay, so that's the last part. I know it was a longer model teach, so I apologize for this, but I hope that was helpful in helping you to facilitate the hands-on portions for these learning targets.
There was a question, and I think I probably missed it in real time. It says, just wondering if that is the order that we are supposed to be teaching it in for some reason. And I'm so sorry I didn't see it sooner. Can you come off of mute if you typed that and just clarify?
Okay.
Okay,
So
if not, we
he can reach
can.
out to us if there's
Yep.
any other
Yep.
questions too, for sure.
Yes.
Okay, so I'm gonna hand it back to Jenna for the resources that are available to support you for these 2 learning targets. Jenna, you're muted.
Thank you. So like I mentioned at the beginning, this portion is going to be a little fast and furious because we're covering two learning targets here, right? So I want you to notice here off on the right-hand side, this first learning target is going to be noted with modeling the day-night cycle. We'll show you the resources for that, and then we'll show you the resources for our second learning target. So here is your curriculum teacher clarification section for modeling day-night cycle. Remember that clarification section is a great spot to go for learning targets, definitions, particular vocabulary, and really just to beef up your understanding so you're best prepared to carry out that content with your students. In the resource section, this is how it looks in your curriculum document. It's days 4 through 7, and you have the 5E layout right there for you. We have the options Amy shared with you. And then we also have a variety of other things that we are going to talk about right here. So there are some additional instructional resources for the Explore. If you were a 5th grade teacher last year and you participated with our virtual presentation that you guys watched, some of them modeled the day-night cycle. And so we stole some of those images with their permission for you guys to see this year. You can also use the Savas Read About It, the literacy station as an Explore. And remember, when you do use that as an Explore, students aren't expected to understand all of the vocabulary just yet. That will come in the Explain, and it has the corresponding activity page. For the Explain, we have the Savas Key Ideas presentation, the key activity, and the video. But also, you probably recall while Amy was carrying out those two learning targets, a lot of the Explain was happening within the moment too, right? So you may or may not find yourself needing to utilize this Savas Explain. That's going to be up to you and your students and how they are grasping the knowledge and how you are able to convey the information to them. For the Elaborate, we found this Scoodle. I believe it's from Australia. I think they have cool little accents when they talk to us. And this is to model the day-night cycle. And then, of course, you can always have your students make a model of their own, right? So we had them make a model with the dowel and the styrofoam ball, but we could provide them with a wide variety of resources and encourage them to make another model and see what it is they come up with to really solidify their understandings. So lastly, we have an exit ticket from Savas, and this one has us explain the causes of day and night on Earth, and it gives them particular words to use. So it gives them a word bank. You could also then support them with a sentence stem if you feel like that would help them be more successful in carrying out this exit ticket. So then we transition to our second learning target here, modeling and observing changes in the appearance of the sun and its shadows that it creates. And so here with the teacher clarification area, I want to draw your attention to appears in quotations, right? Because we want to make sure we clear up that misconception that that the sun is moving. And you guys know it's not the sun that's moving, it's the earth that's moving. So we really want to solidify that understanding for our kiddos with this learning target. The resources, here is what it looks like in your curriculum document, broken up into the 5 E's. And some resources for Explore. We have similarly our Read About It. We have a good hands-on station activity, which is basically what we did in our demonstration here. You can see they have a cute little cardboard cutout person, which would be fun. And then they have a virtual lab here. Now, you don't often see us include the virtual labs because sometimes we feel like they don't really hit the mark. So if you do see it included in there, it's probably a good one for you guys to take a look at with your kiddos and explore. For the Explain, we have our tried and true key ideas presentation and the activity and then the video. If you find that as you're carrying out the investigations with your students that Amy modeled and they're really getting it, lean into that key ideas video. It's short and sweet and it'll solidify some of that academic vocabulary. You can add that to their drawings and their notebooks, right? If you feel like your students really aren't grasping it all that well, then you can lean into maybe the key ideas activity or the presentation to more explicitly teach some of that vocabulary and connect it to the experience they had in the Explore. For the elaborate, Savas suggests some shadow art. So using these materials that you'll provide with them, they will make a sculpture to cast shadows at certain times of the day. So that is a fun way to apply their learning and understanding of the content. And then for the evaluate, there is an exit ticket that's available for you in Savas, as well as the quiz over patterns and shadows. And so these are two great options for us to use. I would like to note here that the Savas one does have models, right? So it'd be good to show them that. And to wrap up and take us back to kind of what we talked about at the beginning, we know that our assessment is kind of a surface level question. You know what your kiddos are going to see on STAR models and things. So as a teacher, some implications for the instruction would be to show them the content in this sort of way to be able to best prepare them for taking that STAR assessment that we just so love, everybody. So lastly, that takes us to supporting our diverse learners. We provide you all with a wide variety of visuals. In our scripted lessons, we provide these first two images to help you have some background knowledge about clockwise, counterclockwise, and to really see that axis and the rotation of Earth. And then in your visual non-glossary that's available on your portal, we also have then the visual vocabulary for rotate and rotation. And this shows us too kind of an overhead view and how it corresponds with a view from Earth and then the time of the day as well. Lastly, we have some sentence frames for you and some sentence stems to help your students. And even if we do not provide a set stem or frame, that's something you can always provide for your students as well to help them be more successful in their learning. Let's see, no SCRs for this unit. Amy, that's a lovely question.
They will be added. Yes, they are created and they're on our menu. They'll be added.
Those are the ones we're waiting for translations, is that correct?
Yes, that's correct. But
yes.
The English ones will be there very soon.
So we have the English ready to go, and the bilingual will be there when they can be there, but the English will at least be there by the time we roll that out. So you guys have done a fabulous job bearing with us as we kind of went through our technical difficulties, and we really appreciate y'all. If you have any questions, please put them in the chat. I'm going to scan this real quick. Let's see, sun anchor chart, adding the times. They need to know how to read an analog clock too. Yes, because sometimes it has that time on there, right, with a regular clock. And let me show you, let me go back to that really quick. I believe we saw that in one of our images. I feel like I saw it because you saying that makes me think of something. It was in, here in the visual non-glossary. Goodness gracious, computer. So not only do we have a traditional clock, but then they have the time here. So some of our students may not have experience with that yet. Amy, did you put that in there? Is that what that is? The short constructed response prompt bank?
No, I did not. Are you talking about the analog clock?
No, I'm sorry. I am looking at the Google sheet, or excuse me, the Google, you know what I mean? The papery thing that we're using for our chat.
Oh, okay.
And yes, someone linked in there that the SCRs that we have available for them.
Ah, okay.
That document.
Okay, I'll take a look at them. Sorry.
No, that's okay. Thank you for that, whoever put that in there. So you can see that we have those SCRs ready to go for you in English. We just need our translations to occur there in Spanish. I'm not going to say if. Do you guys have any more questions that you think might be valuable for people watching this on their own time? Let me go to that document really quick. Navigating all of the things. No? Okay, so I'm going to go ahead and stop recording. Those of y'all who are with us in real time, just wait. I'll put the attendance form up for you all to be able to complete. Let me find my pause. Give me just a sec. Are you sure you